Good morning, everybody. So, yeah, in the last class, what you saw was that if there is a gap on in the STL file, how will you fill that gap? So, continuing with that same theme, so today what we are going to discuss is now if there are more than one gaps and the gaps basically have a, one common vertex and the two gaps have basically one common vertex. In that case, how would you solve a problem? How would you solve the algorithm? Now, if you look at this figure very closely, what you observe is that this vertex 1 is actually common for both gap 1 and gap 2. So the problem actually changes its definition from the previous problem, because in the previous problem we were looking into the gaps as an individual entity, but here what we observe is that the gaps are coincidental or are have a common vertex. They have a coincidental vertex. Now when you have this type of a problem, what will happen is the missing facet algorithm that we were discussing in the last class, that will not be able to identify what happens when the vertex 1 is reached. Suppose I start from this vertex, that is 5 and 6. This is 5 and 6. So if I start from 5 and 6, I go like this, I identify this 5 and 6 edge, then I go to this edge. Now this edge is 6 and 1. Now, once I reach 6 and 1, that is where I have reached over here. Now, there are many edges which are actually missing. There are many edges which are actually missing. So, 1, 5 is one vertex and 1, 2 is one vertex. So, what happens is at this point of time, the algorithm will not be able to decide where it has to move, because it has got two options right now to move forward. Because if you remember, what we said for the closed loop was that the second vertex of an edge has to become the first vertex of the next edge. So this was the logic that we had applied. So now if I start from here, this is the first vertex and this is the second vertex. Let us call this as edge 1. So 5 and 6. So for edge 2, 6 has to be the first vertex. 6 has to be the first vertex. So 6 first vertex becomes 6 and 1. Now what happens at edge 3 is that you have got two edges. You have got edge 1 to 5 and again you have got edge 1 to 2. So now the software will not be able to recognize which of the edges it has to pick up. So it will lead to more errors in the STL file. And as a result, what will happen is at this point of time, your vertex, the identification of the vertex will not be possible because of multiple edges having the same vertex. As a result, error will start to be shown on the algorithm. So now what you have to do over here is you have to think of a mechanism. You have to think of a mechanism so that the algorithm can be suitably modified, or the algorithm has to become more robust so that the coincidental vertex has to be fulfilled. So what happens over here is not much is going to change, except a one more concept is going to come into picture. Rest of the concepts are going to remain the same as we had done in the missing facet algorithm. So first of all, a file will be checked. A file will be checked for the edges. So using the Mobius rule of orientability, all the edges will be checked. Then a file will be created which will store the information of all the edges which have a missing corresponding opposite orientation edge. So that information will be stored and that information will be now used over here. So how will that information be checked? So as you already know, so that information will be checked from here. So first of all, what we are going to do is we are going to check for all the missing edges. So we are going to check for all the missing edges. Now here you have to remember one basic fact or one basic rule, that if you have a coincidental vertex problem, if you are having a coincidental vertex problem, you will never start the first edge from the same that vertex. You will not start your problem from that vertex. So here vertex 1 is the coincidental vertex of gap 1 and gap 2. You will not use vertex 1 as the first edge. Please remember that. You can use any other edge, but not an edge which uses vertex 1 as the vertex. So you can start from 5, you can start from 3, you can start from 2, you can start from, no, don't start from 4, you can start from 2, you can start from 3, you can start from 5. Any of these three vertices or any of these three vertices can be used as the first vertex of a edge 1. So let us see. If we start with 3, so 3 to 4 is this, then 4 to 1, and now again we have reached 1. So we have got two options. We can either move in this direction or we can move in this direction. So since we are looking for all the missing edges, so what will happen is you can take any one in a random order. So 1 to 2, then edge 4 will be 2 to 3, then edge 5, it will be 1 to 5, edge 6 is 5 to 6, and edge 7 is 6 to 1. So you can use any of these orders. So there are 7 edges which are missing a corresponding edge. So this information is going to be stored here in file C. So this information is stored in file C. So now what you are going to do is, now you are going to check for the closed loops. You are going to check for the closed loops. So now you go back and you start your closed looping. So how do you start your closed looping? You already know, you have done that in the last class. So first edge has been identified, that is 3 to 4. Now you go to the second edge. So second vertex will become the first vertex. So now 4 to 1. So this will be taken care of. So here, as you can see, we have taken 3 to 4. Then the 4 becomes the first vertex of the second edge. So 4 to 1 has been taken. Now what we have to do is we have to check for the solutions. Now what we have to do is we have to check for the solutions. Now this has to become 1. So this has to become 1. So what happens is you basically detect all the gaps. So now what you do is, once you have stored that information, you will go about checking, for all the loops. So what will happen is, so the first loop that I am checking is this one. So I have started from here. Let me rub this one. I have started from here. I went to 3 to 4, then 4 to 1. Now over here, I have got multiple options. So what I have, one option is over here and one option is over here. So what I'll do is I'll take 1 to 5 as my first option. So 1 to 5, then E4 becomes 5 to 6, then E5 becomes 6 to 1, then E6 becomes 1 to 2, and E7 becomes 2 to 3. Now, if you remember the algorithm of closed loop, edge 1's first vertex has to become the second vertex of the last edge. Then only the loop is completed. So edge 1's first vertex has to become the second vertex of the last edge. So we have got 7 edges over here: E1, E2, E3, E4, E5, E6, and E7. And 3 was the first vertex of the first edge. And now 3 is the second vertex of the E7 edge. That means the loop has been completed. So there are 7 edges over here. But there is another option available with me. First vertex and second vertex. So if I take 3, 4 as my edge 1, then edge 2 becomes 4, 1. Edge 3 becomes 1, 2, and edge 4 becomes 2, 3. So again, this loop is also complete. So this loop is also complete right now. So you have, as you can see over here, the vertex number 3 is the first vertex of edge 1 and it is the second vertex of edge 4. That means the loop is complete. So now what I can understand is that I have got two options according to the closed loop algorithm. I have got two options according to the closed loop algorithm. The same thing I have mentioned over here. So there are two options. There are two options, and for the first option, what I can see is there are seven edges, and the loop is complete. There are seven edges, and the loop is complete. For the second option, what I see over here is that there are four edges, and the loop is complete. There are four edges, and the loop is complete. So now what will we do? So what will we do? So in this case, what happens is that the option which has the least number of edges, the option which has the least number of edges is going to be filled first. The option that has the least number of edges is going to be filled first. So you had two options. One had seven edges, one had seven edges, and you had an option which had four edges. So this option or the second count will be filled up first. So this gap one is going to be filled up first. So how we are going to fill this gap, we have seen in the last class. So we will create a file, and what we will do is, we from 4 3 and 2 I can create one facet, and 4 1 2 I can create another facet. So using two facets, facet 1 and facet 2, I can fill this gap. So once this gap has been filled, once this gap has been filled, what remains for the problem is that only this gap remains. Once this has been filled up using two vertices, only gap 2 remains to be filled, and gap 2 becomes a single facet which can be filled up using the concept of a missing facet, missing facet. Now what happens is that, suppose you have a problem like this. Now what you observe over here is there are three gaps. Now there are three gaps. There is a gap 1, there is a gap 2, and there is a gap 3. Now gap 3 is separate, and it is completely independent of the other two gaps. So when you have such type of a scenario, here what you will do is, before filling gap 1 and gap 2, you will fill up gap 3, because it is a single missing facet. It's a single missing facet. So for a missing facet problem, what you will do is, you will check for the number of edges. You will check for the loop. This is the orientability. So 9 to 10, 10 to 11, and 11 to 9. You simply fill up this hole using the missing facet algorithm. Now, once you come to this problem, now you come back to this problem. Now here what you observe is the vertex 4 is the coincidental vertex. The vertex 4 is the coincidental vertex. So in order to fill these two gaps, you need to select one starting vertex, which will definitely not be 4. You have to select one starting vertex, which will definitely not be 4. So you have this orientability over here, and you have this orientability over here. So you have got multiple options. Once again, you can start from vertex 7. So 7 to 8, 8 to 4, 4 to 7 is one option. The second option is 7 to 8, 8 to 4, 4 to 5, 5 to 6, 6 to 1, 1 to 2, 2 to 3, and 3 to 4. That is the other option. Then again 4 to 7, the loop becomes complete. So you have got one option is, you go this, here 6, 1, 2, 3, 4, 7. The loop is complete. That is one option. Or the second option is 7 to 8, 8 to 4, 4 to 7. So you have two options, and definitely this option is going to have the least number of edges. Only three edges are there. So this will be filled up first, and then it becomes a single gap. Then this becomes a single gap problem. The gap one is a single gap problem, that again you know how to fill this gap using the missing facet algorithm. So the basic, no, basic concept over here is that you have to check for all the edges that are there. Then what you have to do is you have to select one vertex from where you are going to start. You are going to do one vertex from where you are going to start. After that, what you are going to do is you are going to combine all the edges and look for as many options as you can in order to fill that vertex, and correct that gap. So once the gap has been filled up, whatever remains has to be filled up last. Now once you are selecting the edges, you have to select the option which has got the least number of edges to be filled up first. If there is a gap which is completely independent of the coincidental vertex, then that gap has to be filled up using the missing facet algorithm. So the differentiation between the missing facet algorithm and this method is that if you have got multiple options of filling the gap, the first option that you have to pick is the gap which has the least number of edges. So you will use this algorithm in order to fulfill the gaps, and you will use this concept of filling the holes.